Hello everyone. In today's video, we'll be going over what is left of the internet section. I mean, except for browsers and how they work. I would just record all I know or all I've learned so far about that in another video. Well, we're just going over what HTTP is, what a domain name is, what is hosting, what is the DNS and how it works. So let's start with the DNS. And the reason why I started with the DNS is because it is very first step in establishing communication between your client, you, the browser, and the corresponding server that your whatever you want to access is sitting on. So the first thing that happens is, or the first thing we need to understand is, the servers that your web resource is sitting on are identified by IP addresses, which are internet addresses, right? And we don't know those IP addresses. So we don't know youtube.com's IP address, but we do know that the domain name that is associated to that with that IP address is youtube.com. So when we give our browser youtube.com, what happens is it takes youtube.com. First of all, our browser will have a cache, and in that cache it will go, well, have you ever tried to call youtube.com? And cache is temporary, so it's not like it will always remember it. But if you've done it in a more recent time, you go, oh yeah, I have, and this was the corresponding IP address that I got back. So this is the IP address, right? But we're looking at the worst case scenario, right? In a situation where it doesn't particularly have that IP address stored anywhere. So what happens is it goes to the domain name resolver and it goes, oh yeah, bro, look, I have youtube.com. Do you know the IP address? The domain name resolver itself has a cache of its own. So if it doesn't find the IP address in that cache, it goes to something called the root server and goes, oh look, I'm looking for the IP address for youtube.com. Do you know where the IP address is? That guy goes, I don't have it, but youtube.com has a top level domain of .com. It could be .org, .net, whatever, but in this situation, we're using something that has it .com. I know the IP address of the server that has access to all the .com guys, and it goes to the TLD, and so it gives you the IP address of the TLD, which is top level domain. The DNS resolver goes to top level domain and goes, youtube.com is what I'm looking for. ud.com, like, do you have it? He goes, well, no, I can't. I don't really know where the IP address is, but you know what? I know the hot name server for YouTube, right? And without a doubt, that as long as it exists, that guy probably has it. So it gives you the address, the domain name resolver goes to that server, and then that server gives you the IP address for youtube.com, which your domain name resolver then sends to the browser. Now you might be wondering, well, what's the usefulness of the IP address, right? Like I explained earlier, your browser is attempting to pull web resources from some other computer sitting somewhere else on the internet, right? The domain name, the router of your browser, nobody particularly understands or can identify that server with that domain name. It is only the IP address that it can use, right? So, and it needs the IP address, and that is why you have to do all of this. So essentially what DNS is, or what a domain name server is, it is simply the server that's responsible for transforming your domain name to an IP address. So it is like a phone book. Think of it like a phone book that, oh, I have this person's name, but I don't have their phone number, right? But I need their phone number. Okay, if I was passing the name into that phone book will return the corresponding phone number I need, and that is general gist of it. And that's the first step, right? When you're trying to communicate with a web server to fetch particular data from it. Now, the next step is, let's go to slide 3. So that's domain name resolution. Now that we found that IP, right? We now want to establish a connection with that server. And how do we do that? The very first step, you do that using a TCP connection. So TCP stands for Transmission Control Protocol. And it is what we use to establish connection between two computers, right? And it is also what we use to ensure that data packets are sent. So that is where the transfer of data packets happen, right? And it also helps us, it confirms that those data packets are sent and delivered the right way. So, and that's why we need to establish this TCP connection. And how is a TCP connection established really? Your computer or the client sends something called the synchronized packets to the server, right? But it's always short into like a SYN. the server receives that synchronized packet and goes, I acknowledge your synchronized package, and SYNAC for synchronized packets, not package, acknowledged. And then the client goes, acknowledged. So like the client also acknowledges that it has received the synchronized packet acknowledgement, right? Let's just think of it that way. So that is what happens. Now, the moment the client sends back the acknowledge, right, a TCP handshake is complete, and then you've established a TCP connection. Now, once a TCP connection is established, you can start sending requests between the client and the server, right? Now, that request is called a HTTP request, and the reason it's called a HTTP request is HTTP is the protocol that dictates how data is transferred over the web, right? So that is what it is. A protocol is something that is a set of rules, right? So, and the HTTP protocol is a set of rules that determines how we send data over the web, or how we communicate over the web. Now, it stands for Hypertext Transfer Protocol. So, Hypertext Transfer Protocol. Let's just put that in brackets here. Hypertext Transfer Protocol. Right. Now, well, how does it work? What is it exactly? It is an application layer, it's an application, is layer, whatever it's called. It's an application layer protocol, right? Now, what is an application layer protocol? Well, in networking as a whole, you have something called networking modules, right? HTTP itself is based on something called the TCP model. So there are two modules. Let's just come here. So you have two modules here. Dismiss, close. Yeah, so you have two modules here. So you have the TCP/IP model, and you have the OSI model. Now, to be fair, the OSI model is a more granular model. It offers you a very deep understanding. So we'll first look at the OSI model. So in the OSI model, the levels are it is all people. So all is for application, people is for presentation. So presentation. CM is for session. All people seem to need data processing. So 2 is for transports. Need is for network. Data is for data, and processing is for physical. Okay, so these are the various layers for the OSI model, right? Now, in this model, the HTTP request ideally should sit here, but because it's not based off the OSI, there is more to the HTTP than just the application. But basically, the application layer is for, in the sense of HTTP, is how we define precisely how web data is requested, transferred, and interpreted. And there are a lot of other application layer protocols. There's one for file, I think that's FTP, and there's also for email, right? But HTTP is what we're focusing on here, right? And then you have the presentation layer, which in this layer is where things like SSL and TLS, data formatting, data compression, and so on, that is where it happens. For sessions, this is where session management happens. Now for transport, that's where the TCP is. So the TCP connection that happens on this layer, right? Now for networking, remember when we're talking about setting up a LAN and what the internet is, and we said a router is how you connect to the internet, and it's how different networks speak to each other. So here is where your IP address sits. So your IP address and the router you're sitting on the network layer, and your routers use the IP addresses to locate other computers over the internet, right, and speak to those computers. And then you have data. So data is, think of like your LAN, that's that very tiny network, right? That is offline and not connected to the internet, right? So data uses MAC addresses. The MAC addresses that data uses, it uses a switch and a MAC address. So, and your MAC address is only relevant typically over a LAN. So, and yeah, so that is what is on data layer. And then processing layer is Ethernet cables, like hardcore stuff, physical. This is physical, not processing. Yeah, I mistook those things. Physical layer. So that is what it is, right? So you can think of these as HTTP, FTP. In this guy, think of TLS, SSL, uh, data processing. And this guy is just session management. In transports, we have TCP. In network, we have IP addresses. In data, we have MAC addresses. In physical, we have Ethernet cables. Essentially, those are like the things that define those different layers. Now, that's the OSI model. Now, the TCP model, which is what HTTP is actually sitting on, is a very interesting one. Because for the TCP model, think of everything we've talked about, right? So you have an application layer too. And just think of it as a combination of the app layer, presentation, and session layer in the OSI. And then the next layer it has is the transport layer, which is same as OSI transport layer. And then you have your internet layer, which is the same as the network layer in OSI. And then you have your link layer, which is the same as the physical and data. So it is physical data layer in OSI. So, and that's what both of them are. So an HTTP falls here, right? So your TCP falls here, right? So, and you can see how all of this is layered. So you have Ethernet cables connecting the entire globe together and created the internet. In that same layer, you also have your LANs, right? Your MAC addresses using a switch, and this switch is using the MAC address to communicate with each other. And then you have your transports, there's there, and then there's an internet layer. So and in your internet layer, what happens here is IP addresses and routes where different networks are now communicating to each other over the internet. And then you have your transport layer where the TCP connection happens, which is where the protocol that ensures proper data communication between two computers is enforced. And then you have your application layer where HTTP is sitting on top. And that is the general gist of it, right? So, and that is what HTTP is. So now we will talk about sending. Once your TCP is connected, you send HTTP request. Now, what is HTTP? What is a HTTP request? What does that look like? So HTTP request, right, it has a particular structure. If we're to open the inspect page for this guy and went to network, can we find anything here? I mean, yeah, we could. So this is what HTTP request looks like. So this is the typical structure for HTTP request is it has the start line, which has your method, the path / URL that you want to call, and the HTTP version, right? So this is the method. So methods are get, post are the most popular ones, where you have put, delete, and all of those things, right? And then you have the request URL, this guy, and then you have the HTTP version. So it could be version 1 point something, right? And that's what is there. And then you have headers. So these are request headers. So this is what the client is sending to the server. So the request headers, right? It is usually a key value pair, right? So it is accept text CSS, TCSS, accept encoding, accept language. Those are the keys, and these are the corresponding values, right? And then it will have the actual request body, right? And it will send that over to the server, and then server will receive that, and then send a response message. So, and your response message, it also has a typical structure, only that it doesn't have a method or a URI in the response message. It just has the HTTP version and the status code. And you have also status codes. I will look at status codes further. So, and it sends status code. So in this case, status code is 200, which says, oh, you are good to go. Everything was received correctly, everything has been sent correctly to you, right? You have 300, 400, and 500, right? So, and then he has his own headers too, like, which are also key value pairs. And sometimes it will come with a response body if the response has a response body, and it could be a JSON, it could be anything at all, right? So we're looking for a response here. So this is what this guy sends, right? So this is what is in the response body that came back from that call. We could do a quick Google search and look at response codes. Generally, you just need to understand what each group represents, right? So there is usually it's the 200, 300, 400, and 500, right? So 100 is interim response in case that the client should continue the request and ignore the response if the request has already finished. 200 represents successful requests. 300 is redirected requests. 400 is client error request. So that is usually you sent a bad request, you sent an unauthorized request, it is forbidden, or the page wasn't found. So the page you tried to access wasn't found. And then 500 is usually server errors. So that's something has failed on the side of your server. And it has nothing to do with you, but it has everything to do with your server. So those are error messages in a nutshell. Now, as far as HTTP goes, that's the big thing there. There's just one other thing about HTTP. When data is being sent with just HTTP, it is sent in plain text, which means anybody can intercept that data and read what we're sending. So imagine credit card details, your password, all of those things. Over HTTP, there's no encryption at all. So anybody can read that as long as they can intercept it. Enter HTTPS. Right, so HTTPS is the guy who said we shouldn't really be doing that, right? We really shouldn't be communicating over the internet without any proper security checks, right? So, and how does HTTPS work really? So, assume everything so far has happened the same way. You've done your domain name resolution, you've established a TCP connection, right? That is where things start to get slightly different. So for HTTPS, what happens next is something called a TLS handshake. So a TLS handshake is essentially the client sends hello. There's a client hello sent to the server. The client hello contains something called the TLS version of the cyber suite. Cyber suite is essentially a list of encryption algorithms, right? The server sends back a server hello saying, oh, this is the TLS version I've chosen and this cyber suite will be using, right? So of all the cyber suites you've sent, this is the one we'll use, right? And then the server sends a certificate along. Now, certificate contains a whole lot of things, but the key thing that you need to pick from a certificate, right, is the public key. Now, when that is sent back to the server, when that is sent to the client, the server hello is done. Right, so and that certificate is how the client knows that I am communicating to the right person. Right, now, what happens after the public key is received by the client is that the client usually, so there's something called like asymmetric encryption where the client will generate a session key and then encrypt it with the public key that was given to it or that it took from the certificate, and then it will send that encrypted public key to the server. The server will take the encrypted public key, that encrypted session key, and decrypt it with its public key. And now both clients and server have a session key. And then all corresponding messages that are being sent over the network between both of them will be encrypted using that session key, right? So, and that's the general idea of what HTTPS is, right? So, once that key exchange happens and the encryption happens, this is TLS handshakes ends the moment the server hello is done. and then the key exchange happens, which is where your session key is encrypted by the public key, the server decrypts that session key, and both of you have a session key now, and then data transfer happens, and that's what HTTPS is, and that is all of how data moves from one point to the other over the internet in very simple terms. That is all of this domain name page space. Hosting is essentially I have built a web page or a website or an application, right? I do not want it sitting on my own personal laptop. I don't want people access it for a lot of reasons, reliability and all of that. So you know what? I'm going to put it on someone else's computer, and then you can access it on that person's computer. And that computer is actually way more powerful than mine, right? That is essentially what hosting is. So um, if you heard anything that I feel is incorrect over the course of this video, I'd like you to reach out, put a comment down, like, oh, you said this is wrong, and we can have a discussion about it. Any suggestions or whatever, I'm open to all of it. Thank you so much for whoever is going to watch this, for following me on this journey, and I'll see you in the next one. Bye bye.